Today we are going to do this one. That's one of the popular name reaction, HVZ reaction, Hell-Volhard-Zelinsky reaction. The reaction which is going to take place, the carboxylic acids with alpha hydrogens only undergoes this HVZ reaction. What's the advantage of these means? It's useful to prepare alpha hydroxy carboxylic acids as well as amino acids. Of course, some more uses like in industrial field, monochloroacetic acid, dichloroacetic acid, trichloroacetic acid, like we are getting brominated and chlorinated products, children. So this is the brief concept of HVZ reaction. What is happening? What is the reagent which we are using means red phosphorus in presence of Cl2. It's going to be a red phosphorus in presence of Cl2. What is happening means step by step the alpha hydrogens are going to be replaced. In the first step, the product X is going to be, it's called monochloroacetic acid, Baba. It's one of the very big industry to prepare alpha hydroxy carboxylic acids as well as like amino acids also. And after that, in the second step, whatever we are doing in the second step, that's going to be what we are getting here means first step is this, and second step is going to prepare what we are getting, nothing but known as here DCA, dichloroacetic acid. And in the third step also the same reagent which we are using, that's we are getting here Z. Z is nothing but trichloroacetic acid. So this is the brief conceptual relation of HVZ reaction, and I'll show you the minimum application of this one. Once you have taken the monochloroacetic acid, when you have taken, Baba, monochloroacetic acid that we have shown in the preparation of this first step of this one, then what is happening means whenever it is treated with aqueous KOH, it's going to give us, it's known as here 2-hydroxyethanoic acid. 2-hydroxyethanoic acid here, children. And after that, if it is treated with alcoholic KNH2, potassium amide, then it is going to give us alpha amino carboxylic acid. This is going to be known as here glycine is the amino acid. Like this, we can prepare hydroxycarboxylic acids as well as amino acids. One of the condition which are not undergoing this one, what are not undergoing HVZ reaction means, in general, which are not having alpha hydrogens, they are not going to be showing this HVZ reaction. So this is the basic concept of HVZ reaction. Most probable expected question also, children. So that which we are going to do with this HVZ reaction is most popular reaction. After that, we will also go through that another reaction which is nothing but which are having alpha hydrogens that are called the aldehydes with alpha hydrogen, children. That's nothing but known as here Aldol condensation. What we are going to do is nothing but Aldol condensation. So, what's the Aldol condensation? Aldol, it's nothing but aldehyde plus alcohol. It's called Aldol condensation. One of the best reaction here, that's nothing but which are having alpha hydrogens, they undergoes aldol condensation. It's a nucleophilic addition reaction. So this is, that's going to be the aldehydes with alpha hydrogens will undergo. Aldehydes with what's called here alpha hydrogens will undergo this reaction, Baba, here. Undergoes aldol condensation. This is the first point, children. The coming to the second point is concerned. There are various examples we can go through this that are going to be like which are having alpha hydrogens, that's going to be CH3CHO, and also like what's called here CH3, CH2, what's called here CHO, and like that, which are having alpha hydrogens, they'll undergo Baba here. This is going to be known as here one of the best relation, like which is having CH2, CHO, like this benzene ring. This also undergoes what's called here Aldol condensation, of course, though it is affected by resonance, children. So this is all the cases where they are undergoing Aldol condensation. We can go any extensive number of examples also, but this is going to be what's called here a nucleophilic addition reaction. It's nothing but what you say here, nucleophilic addition reaction. For example, children, we will take CH3CHO, that's going to be two molecules in presence of base, that's going to give us what's called here CH3CHO and CH2, CHO, children, that's a bond. This is called aldehyde plus alcohol, aldol. And when you are going to heat at this, Nana, it's going to give us alpha beta unsaturated acid. That's nothing but what you say here, alpha beta unsaturated acids, like what's known as here alpha beta unsaturated aldehydes. Extremely sorry, children. So that's going to be a crotonaldehyde, like you listen the name of croton plant, crotonaldehyde. That's going to be the crotonaldehyde, Baba. So this kind of example in which one of the molecule is going to be converted into nucleophile, like I'll show you the brief mechanism of this, children. What's known as here one aldehyde, this is going to be in presence of 50% sodium hydroxide, like 50% sodium hydroxide, it eliminates alpha hydrogen, then it gives a nucleophile like this. This is going to be attacking this one, another aldehyde, that's going to have like this. This will attack here, this will shift here, and again H plus transfer will take place, Baba. That's going to give us what you say CH3, CHOH, and also known as here, that's known as here H, and this is going to be what you call as here OH. Okay, now this I have shown you, this is called aldol here, children. This is an example of what is called here intermolecular, what you know as here intermolecular aldol condensation. It's called intermolecular aldol condensation, Baba. So that, children, this is the main points which we have to see under the heading of this one. I'll go another one also. This is all going to be intermolecular aldol condensation. The next one also we are going to do. Example number 2, exempli gratia number 2, that's which we are doing intramolecular aldol condensation. Intramolecular aldol condensation also. I'll finish this part, children. Let me take some time. Intramolecular means within the molecule. So CHO, that's going to be CHO 1, 2, 3, 4, 1, 2, 3, 4, 5. I have taken. It's called 1, 2, 3, 4, 5. 5-oxobutanol. It's nothing but 5-oxobutanol. Butanol or butyraldehyde. Oxo have used the term in the prefix here. Suppose if you have taken like this, no, in presence of base, what's going to be happen? I'll tell you, children. Let's go through this. This is the intermediate that will go and attack here this carbon. Let us see like this. And here what is happening means, that's nothing but, let us go through this mechanism also. First of all, it will convert into either here or here, it's going to be converted into carbene ion. So the carbene ion is going to be the nucleophile. Then after conversion into this alpha hydrogen elimination, this will go and attack what you say here, children, this carbon, carbonyl carbon. After attacking this carbonyl carbon, this will shift. this will become CHOH, and also what is happening, children? After this, CHOH means let's write the structure like this. It's called CHO. When you are, it's going to be a cycle. How many numbered cycle, children? 4 numbered cycle. So that once you got this, when you attach this one, no, this is going to have what's called here OH, and this is what you known as here this one. Followed? So after this, children, 1, 2, 3, 4, 5 carbons are there. Now it's called intramolecular aldol condensation. Intramolecular aldol condensation, in which that's going to be losing this hydrogen. When you are heated this, no, the probability to remove this hydrogen here, because it's going to give us, it's called alpha beta unsaturated carbaldehyde, children. Alpha beta unsaturated carbaldehyde. So cyclic aldehydes we are going to get. This is an example of what you see, intramolecular aldol condensation, while it is going either at this alpha carbon or at this alpha carbon, or else it's going to be here. In this case it will take place, Baba, here. After this, one of the carbon converts into nucleophile. The nucleophile attacks carbonyl carbon, and the intermediate which you are going to get like this, and here there is a probability of removing this hydrogen and this hydrogen, but mostly preferably the hydrogen is going to be tertiary hydrogen eliminated very easily. That's going to give us cyclic carbaldehydes. That's going to have elimination of water is taking place upon heating, children. This is about intermolecular as well as intramolecular, and some more questions. While I am doing paper, I'll also solve these questions here. It's a best question. From these two, from this session, this is also one of the most expected question in the final examination. You can see this in your papers also, last year and before last year, etc. More or less frequent question, children. The exceptions will be done no sooner. Thank you, children. Thank you very much. Thanks a lot.